Hey, everybody. Do we all enjoy the ice cream? Yeah, I'm enjoying my whiskey. I did come from Scotland, so yeah, thank you for coming. This talk is on, as you can see, why you should be using web components now and how. I've been a bit cheeky with the title. You'll work out why later on. I work for a company called Pusher. Out of interest, who's heard of Pusher? Few people? OK, I'm going to say 25% because this is recorded, so it's going to sound better. So, I mean, they flew me out here. I need to, say Pusher's a hosted service that helps you integrate real-time data into web, mobile, and IoT applications. Basically, a real-time layer that sits between your backend, so PHP, .NET, Java, whatever backend you've got, and the client, whatever the client is. Before I worked for Pusher, well, I've actually worked for Pusher twice. I rejoined them again in December. I had a year and a bit out, and I worked on a framework and toolkit called BladeRunner.js. And it was all quite new to me, but I'd worked for the company Kaplan Systems beforehand. And when I went and joined them, I did so through kind of faith that they knew what they were doing, rather than really understanding what this BladeRunner.js toolkit did. So I spent a year and a half kind of learning around the concepts around building large single-page front-end applications. And what it fundamentally came down to was building modular front ends, building component-based front ends. You'll likely want to hear that. I knew they were going to put that video in there, so I kind of growled at the Giganotosaurus, so I was quite pleased with that one. And that's where my kind of my love for web components came from. I understood the benefits of building these modular front ends, so I wanted to focus on. So when I found out about web components, I kind of went, OK, but that's exactly what I've been talking about, except natively supported in the browser. So I'm going to cover 4 different things. I need to cover what web components are now. Who here already knows what web components are, and they're going to be kind of dozing off? Right, a few people. Sorry, I mean, I've got to cover that because there are people here that won't know what web components are. But I want to show the fundamentals. I want to talk about the state of web components, talk about componentized web apps and what that means, and then how that feeds into making web components the future of front-end development. As I kind of said, Anyone? It's a little bit dry. What are web components? I'm just going to tell you what they are, and I'm going to show you how to use them. I've seen lots of really good talks on web components that make people turn down the lights, and it uses the camera detects the change in light and flashes the screen. And that's awesome, but it's not showing you fundamentally how to use web components. So I'm going to show you the fundamentals with a very simple example. Most people know web components are custom elements, HTML templates, shadow DOM, and HTML imports. Firstly, custom elements. HTML, we probably all learned HTML through going to a website, viewing the source, understanding what happened, following links through, looking at JavaScript, looking at CSS. And we've lost that now. We still get the occasional web page that has real semantic meaning, and we can just look at the source and understand how it works. But the common example that you'll see, Eric Beidelman, who's been working on the web components team at Google, uses this example. Anybody that talks about web components uses this example, is that in applications we have div soup. We can't look at that source and understand what's happening in that application. There's no meaning to that structure anymore in the HTML. So custom elements have the potential of going away to help us bring back that meaning to our markup. They're also more than just markup, and I'll explain why. And I think they're fundamentally the core of web components. So it might be, now this is probably a bit controversial, it might be that a new Gmail would look something like this. We've got our head, we've got our body, we've got our header now because we've got HTML5 elements as well. And we actually have custom elements that define specific pieces of functionality for our application, so Gmail search, Gmail account strip. Now, there are arguments for and against this, and I don't have time to cover that today. There might be a Gmail sidebar with a navigation element, which are our Gmail labels, the ability to filter the actual emails that we're seeing. We've got contacts. We've got a main, which is obviously the main section in Gmail. Maybe there's a nav in there, which is our categories, the filters that Google provides at the top level around promotions and so on. And then our Gmail list. And then we might have a standalone Hangouts element. Now, as I said, that's kind of probably way too far to making custom elements be, you might as well just have my app. There are arguments for and against that. So I have given a talk specifically on that at Web Components London at Mozilla about a month ago. So if you're interested in what should be a web component, and the pros and cons of approaching that in different ways, then please look at that talk. So I'm going to dig into just simple custom elements. So I'm going to look at an avatar, which is a really, really simple example. Here I've just got images. I'm using avatars.io for a bunch of different things. I don't actually have an Instagram avatar. And down the bottom, I've got a Skype URL. So, loads of different ways of bringing in an avatar. So let's build that in custom elements. It'd be nice if I could do that. My avatar, identify the service, in this case Twitter, the username Legator. So to do that, I take the HTML prototype and create my own prototype from that. I'm defining an object. We're diving straight into JavaScript to define our custom element. There are a bunch of lifecycle callbacks in custom elements, and I'll mention those in a bit. But the created callback is when, obviously, that element is actually created. So I'm referring to this, and this, in this case, is the element itself. So it's the my avatar element. So I can do this.getAttribute username, which gets me Legator, and this.getAttribute service, which gets me Twitter. I can build my URL, avatars.io/service/username. I'm going to create an image element. I'm going to set the source attribute, so I'm going to use that image element and fetch that image. And I'm going to append it to this, which is the custom element itself, which is the my avatar. You need to also register that element with a document. So I'm saying register element, my avatar, and the prototype is that object that I've just constructed. And then I can use it. So really simply, I've got my avatar service, Twitter, Legator, Instagram, Legator, and Twitter and forward.js. So I'm straight away using this custom element. So it's a really simple example, but it gives you an idea of the sort of things you can do. You can also extend existing elements. So in this case, I'm taking the image and inheriting all the functionality that it provides already. I'm saying it is a my avatar X, so a new type of custom element that I've defined. Putting two properties on it again. To define it, I'm actually taking the HTML image element prototype, created callback, I'm getting the username, I'm getting the service, I'm building the URL, and I'm using this, which is now an image, setting the source and setting the URL. So I'm getting that functionality that the image provides already. Registering it, I need to say that the prototype is the object I've created again, and I need to say that I'm extending the image tag. Now, the good thing here is that we can extend existing functionality that's natively supported in the browser. The main benefits around this are around accessibility, although, unfortunately, there's a bunch of concerns around that. I'm not going to have time to go into detail, but I'm going to highlight it, that there's some questions around this idea of extending and how you do it. The lifecycle events are created, when the element's created, attached when it's actually added to the DOM, detached, obviously when it's removed from the DOM, and attribute changed. So if I look at my inspect element, can people see that all right? So here, if I change the username to forward.js, nothing happens. So this is just a my avatar X. However, down here I've got another one, which is a my avatar changer. And then now if I go forward.js, I've got a callback that's registered internally. You'll see the URLs change as well, and I can just write code that changes that URL. So that's exactly what attribute changes do. It's really simple. Because these are custom elements natively supported by the browser, we can do everything that we can do with elements that natively live in the browser that aren't custom elements. So I can use JavaScript to create elements too. So in this case, I'm going to create too many fills, which is 104. I wanted to do a do-while loop just because I never get to do them. And I'm going to create each of these my avatar elements, set the attributes, add them to the DOM. Again, really simple. Pretty boring. Anybody? Anybody? This is a slide as well from Eric Weidelman's talk from Google I/O 2014, and he highlights the benefits of this. So the browser understands custom elements. It understands elements, so we get all the benefits of that. We can use all the existing functionality that the DOM offers on these elements, and we also get the performance benefits, the optimizations that the browser understands how these elements are formed, how they're rendered, and how they're structured. Eric pointed out that you get interoperability. So the base level of the browser now will be web components. So you can take a web component that you define and use in Angular and take it away and use it in Ember and take it away and use it in React. So we've got a different level, base level, and we can reuse these elements across different frameworks or libraries. Accessibility is something that is generally hoped to be something that we'll get from this. If we're extending existing elements, we should be able to access some of this accessibility and benefit from some of this accessibility that's supported because the browser understands these elements. There are some concerns around this right now. And developer tools, you've seen already that I can start messing around with the elements that I'm defining. So because the browser, again, understands how these elements are structured, we can use our developer tools straight away on them. We don't need a specific extension or add-on to start developing and debugging what's going on with our elements. Templates, I don't need to spend much time on this. Who uses some sort of HTML template library? Come on. Everybody. Okay, so there's loads to choose from. So it kind of makes sense that jQuery had the ability to query the DOM based on CSS. So the things that we do commonly, we hopefully, W3C listen, the browser vendors listen, and they move to be natively supported. So it makes absolute sense that the HTML templates move to be natively supported. There's a bunch of things around string manipulation, inefficiency, cross-site scripting, injection, and all sorts of problems that can be seen if it's not natively supported. So we'll let the browser deal with that now. So we've now got a template element. We can chuck whatever we want in it, and any valid HTML with a few caveats. And then to use them within our web components, our custom elements, we can get access to that, in this case, something with an ID of my avatar template. We access the content property on it. So one of the benefits with templates as well is that they're inert, which means they don't actually affect the document until they're actually added to it properly. Just the template element on its own doesn't affect the DOM. It's not going to affect it's not going to be rendered to the screen. Not until you've cloned it and actually imported it into the DOM does it have any effect on the document object model. So we've got this content. We then need to import it into the actual document. True means I'm going to deep clone. I'm going to make sure that I'm copying all the contents, so all the nested elements as well. This gives me the element, not the elephant, the element that's created. And then I can dive into that, select elements, set attributes, set text context, and then append it to this, which is the actual custom element. So here's, as you can tell, I'm pretty awesome at design. This is what's created. So you'll see I've got my avatar, and all this content is chucked in the middle. We register it in the same way. So we're doing these in libraries anyway. It makes sense to move it to native. We're getting again, as with custom elements, because it's templates, because it's native supported, we get all that benefits. It's lightweight document fragment. When we clone it, we're not getting all the stuff that comes with the document, just the document fragment. And as I said, it's inert until it's actually cloned or used. Shadow DOM. Now, Shadow DOM is probably the one main sticking point that the browser vendors are discussing and going back and forward about. The idea is to provide a level of scoping so that we have some encapsulation within our custom element. It gives a level of protection to both the page and the element. I'll go into some more detail on that. Most people, again, have seen this example. We've already got the Shadow DOM. You probably need to turn this on in DevTools. But you'll see video, shadow root, div soup. So the shadow DOM already exists, and the browser's already using it, so it makes sense for them to expose that sort of functionality to us. It's the same problem with accessibility, actually, at the minute, that the browser provides a bunch of accessibility functionality that the browser vendors can use, but we can't quite use that yet. But the shadow DOM is being exposed to us to use now. So you'll see here that I've got a span element with a class of container. Now, I brought in the element previously, which had defined a style of container, that time gold. This new one that I'm about to create has a container style with a background of cyan. So if I bring that in, unfortunately, the style element gets added to the page, and it bleeds up into the page itself and overrides any existing styles that exist, existing styles that have already been defined elsewhere in a style sheet or so on. So the Shadow DOM should solve that problem. It will make sure that when we add that, we add some HTML to the Shadow DOM, it won't bleed out into the page itself. It also provides that level of scoping, so we know we can only have one ID, an ID must be unique within a page. Now, within that document. So now an ID must be unique within that Shadow DOM itself. So if you have quite a nice small component, and you've got a template in there, you can actually use IDs to uniquely identify elements, and you can start to use IDs again, get element by ID. So it's quite nice that it offers that sort of functionality. So to use it, again, I'm having my template here. I'm going to create a new my avatar shadow prototype. I'm going to grab the content, which is the template again. And this time I'm going to use this.create shadow root. So that creates a shadow root object. And then I'm going to import the template into the shadow root. And then I can query the shadow root and then set the attributes as I did previously. So if I actually create an instance of this and inspect this, we'll see that I've got my avatar shadow, I've got a shadow root, and then the content in there. And I've got a background color of red. Now if I go back some slides, it hasn't bled through to these existing ones, which is good news. OK, so we're getting that DOM and CSS scoping. The page can't bleed in to the shadow DOM. You can't, if you define the same style and use it in your shadow in a template that you add to the shadow DOM, it won't bleed through, so you won't override any styles. And you get natural encapsulation. In the same way as the shadow DOM doesn't bleed out. HTML imports, again, there's some questions over this. The idea is simple loading and dependency management. A lot of the stuff here, one of the reasons I like it is that I'm not that clever, but I understand web components, and I understand the benefits of them. And HTML imports, for me, are quite a simple concept, but quite powerful. Again, I think this is the example that Eric Bardelman gave again. This is Bootstrap before. We include style sheets, we include JavaScript, a jQuery dependency, a bunch of other Bootstrap-specific JavaScript files. And afterwards, we simply import bootstrap.html, which deals with all the importing of all these dependencies. So a simple example of this, taking the idea that we've defined avatars, is that we can actually compose other elements out of existing custom elements. So I can create a team pusher. I can import my avatar that I've been using previously. I can define a template, use that avatar custom element, and identify all the people that work for Pusher. I can then register it with the DOM, and then to use it, I simply import it, add that tag to the page, and I get the resulting composed custom element. Well, an element composed from another custom element. Again, quite a simple concept, and it kind of makes sense. So we're bundling, we're getting the value of that. We're getting some form of dependency management, very simple. And it's promoting sharing, reuse, and obviously that idea of composition. There are a few gotchas, just things that I want people to be aware of as I dug into this. When the HTML import is included, you need to wrap that content in a closure and pass in document.currentScript. Then grab hold of this owner document so that you're referencing that HTML that you've imported. Because later on, if you make calls from the page, like make a call into a function you define in your custom element, then the document will refer to the page rather than the actual HTML import. So that's just something to kind of be aware that, oh, what's this current script thing that Phil mentioned? The other thing is, when I went through this initially, I was using clone node to bring in the template content into the document, and for some reason it broke. So again, this is like just a gotcha. I don't really understand why that happened. So I ended up having to change all my examples to use import node. Something else that I thought would have been supported is that within templates, I wanted to use other style sheets. So I linked in some of the style sheets, and I got this error which says HTML element link is ignored in shadow tree. I didn't try script. So again, something else to just be aware of. So that's the four constituents of web components. So what's the current state of things? So I kind of briefly mentioned these as I went over them. So this idea of there are concerns around accessibility. So that might go away at some point. It's been referred to a wart on the custom element spec. The point at which the custom element is actually upgraded from just being a dumb piece of markup to actually being the shiny custom element is different with custom elements than it is with natively supported elements. So with natively supported elements, say select, say input, it's actually rendered at parse time. With custom elements, it's kind of ignored on the first parse. On the second parse, it's upgraded. And there are some concerns around this, and that Christian in his talk earlier mentioned about moving to ES6. That was part of the deal of solving this. So the point at which, I don't know as a developer whether it necessarily matters to us, although there may be some timing issues to be aware of. Again, think about that point of upgrade. Custom elements might change. Templates, we're all good. So that's one thing. Shadow DOM, there's a whole bunch of things. You can define your custom element, and you can define your content. It's just an XML element, so you can put content in there. Now, where that content goes in the rendered custom element needs to in some way be configurable. So the idea was that you could, within your, say, template definition that was used within your custom element, you could select, say someone put a span in the middle of your custom element. You could use this syntax to select, well, if someone puts a span in there, it should go here when I build my actual custom element up. There are some questions around how that's going to work. So that's ongoing. I think Apple specifically are pushing for being able to make the shadow root inaccessible so that you can create it, but then as a developer, you can't dive in and hack the contents of that. The idea of protecting a custom element that's maybe been provided by a third party. So create shadow root will likely at some point have an argument that you pass in. There's also ways of, you can style the contents of a custom element, shadow piercing combinators, CSS properties. And again, there are some questions around how that should be done, whether it should be just CSS properties. So as you define your custom element, you say you can override these things in CSS, but you can't override anything else. At the minute, it's a free-for-all. You can just use these shadow piercing, so that might change as well. HTML imports, Firefox aren't going to do it right now. They're thinking that JavaScript module loading is potentially going to might solve this problem. Again, Christian mentioned that earlier. It could be right, and it could be that we have to wait for ES6. I really hope not, because obviously I want people to be using web components now. 2 pieces of essential reading for this. Wilson Page from Mozilla wrote something on the state of web components, and the Microsoft Edge team did a couple of blog posts recently and go into this in a lot of detail as well. So I'd recommend you look at those. State of browsers. Again, Microsoft are pushing the web forward. They are developing template. The rest of them, although it says under consideration here, it is actually on the backlog on their user voice forum. So they are looking at these things in proper detail now, and also they're involved in the discussions. Apple, we generally don't know what they're doing, but if you dig deep enough, you can find that they are actually contributing. So they're talking about custom elements, they're talking about Shadow DOM. They're actually the ones that wanted, they're very keen in this idea of open-closed Shadow DOM, and which should be the default. So what's the state of things? I think I've got. Unfortunately, we know that Chrome, Google are pushing this forward. So Chrome uses Blink, Opera uses Blink, so we're good there. Android browser and Chrome, we're good there. But for IE and Edge, Firefox, Safari, we're sitting at 25% or 0 in some cases. As per usual, we rely on polyfills for this sort of thing. There are questions over whether you should be using polyfills or not, or whether you should be doing feature detection or progressive enhancement. Out of interest, who can say that they will develop something and it will only work in, say, IE 10? Okay, nobody. So polyfills might not even be an option for you. But this is where the next bit comes in, componentized web apps now. Again, referring to Christian, he wrote a few blog posts recently, one saying that web components were on the edge of extinction. And I don't know whether this was part of it. It might have been a slightly separate one. But it said, when we asked a very captive and elite audience at EdgeConf about web components, nobody raised their hand that they're using them in real products. Is anybody here using web components via the polyfill in a real product? Nobody. He's got a point. But does that mean we shouldn't be thinking about building componentized web apps now? I don't believe so. And we should be building them anyway. And hopefully, I'm going to prove that we're doing that already. And we're doing that already because we're using JavaScript libraries and frameworks. So Angular, include Angular. define an ng avatar. So we're going to create a directive called ng avatar. We're going to say you can instantiate this directive via an attribute, via an element, or via a class. We're going to say that we've got two attributes on it, service and username. I'm going to define a template, which is an image, which uses avatars.io/service and username that Angular deals with the binding of those values. And then going to add it to the DOM. Looks familiar, doesn't it? Let's have a quick look at that. OK, ng avatar, and then there's an image in there. Looks familiar. Ember.js. Who uses Ember.js? OK, a few people. This is Ember.js 1. Include a bunch of stuff. I'm going to create an EM avatar component by extending ember.component. I'm saying there's a URL function that builds up the URL, avatars.ir, this.get service and username. And I'm saying I've got two properties, username and service. By convention, I have a template which is named component/em avatar, which builds an image, which binds the attribute source to a URL. And then I use it by defining another handlebar template that is actually the app. I do have an example of that working, but I couldn't get it working in the slides. React. I'm actually going to do my transformation in the browser. I'm going to define a class. I'm going to say render. I'm going to build an image, avatars.io, this.props.service, this.props.username. I'm going to have an RE avatar. Now, I've actually hard-coded these. There would have been a nicer way of doing this. But I'm saying RE avatar, service Twitter, username Legator, and I'm cheating a bit here. I've got this RE avatar. I should be really be grabbing the attributes from that. Let's inspect this. OK, RE avatar. There's no shadow DOM there, so it's not using web components. A few people think they're using specifically web components when they use React. They're not. You're not. Anybody use Polymer? OK, a few people. So this looks like the sort of diagram that I would create. But this is actually on Polymer 1.0 documentation. So the idea of Polymer is that it's saying the baseline of building functionality for the web now is web components. Web components will exist within the browser. Polymer is a library on top of web components, and it uses custom elements. Let's see how we use that. We have to include the polyfill right now. We include Polymer via an HTML import. We define a Polymer element with the name of PO avatar. We say we've got two attributes, service and username. We build an image. We have service and username that, again, Polymer deals with the binding of those values as they change. We register the PO avatar, and we use it. And this is the output. And the difference here is it's in a shadow root. This is a real web component. So could I ask those that use Angular directives and apps to put their hands up, please? And please be honest. I want to see how many people. OK. Right, keep your hands up. Who uses Ember components? Keep your hands up, those that use Angular. Right. Who uses React? Keep your hands up still. Knockout components? Vue.js components? Backbone components? CanJS? Famous? OK, anything. So I'm going to say that 25 to 30% of the room are using components in their apps. So if you're using components in your applications, then you're already building componentized web apps. And if you look at the way that we built those components in that way, they very much align themselves with web components. And whether that's coincidence or whether they've been speaking, the browser vendors and the library vendors have been speaking. And ultimately, that's how we need to align ourselves to using web components now and in the future. We need to think about building componentized web applications and continue to do that. And eventually, we will be using web components. And that's why web components in the future. As I said, 30% isn't bad. I think some people are shy, so I'm going to say 50 for the record. So the trends, the library usage, is aligning with web components anyway. If you look at the Ember documentation, they say Ember's implementation of components hews as closely to the web component specification as possible. Once custom elements are widely available in browsers, you should be able to easily migrate your Ember components to the W3C standard and have them used by other frameworks. So that's actually specifically what Ember is aligning itself with. If you look at Angular 2, you start by defining a component. Now, whether or not it will render a web component under the hood, I don't know. Maybe it will if the browser supports it. It won't if the browser doesn't. Interestingly here, it's my app. So even the app is a component. So you really need to have a strategy. You need to understand whether the library is going to deal with migrating to using web components and getting all the benefits of native browser support with that, or you need to have your own strategy about making sure you've got a way of migrating at least that DOM layer to using web components. So a good example of that is splitting out your UI rendering logic with your business logic, because then you can ditch your library-based rendering logic, keep your business logic, and just change to using web components rather than whatever library you're using. Again, talking about trends, all the browser vendors are on board with this, at least working together to try and define this and fix things. Demand. So this is the Microsoft Edge Developer User Voice Forum. Obviously, auto-updating IE would be nice. But position 2, Shadow DOM. Position 3, custom elements. Position 4, template elements. Position 5, HTML imports. So people want, developers want web components. And I would argue, based on my experience previously and at the time I spent on the Blade Runner JS team, is that it aligns itself with component-based development, which is a good software engineering development practice, whether it's from server-based development or client-based development. This is a bit woolly, but you're getting natural separation concerns. It depends on how you build your components. What is your component? But if you take this approach where you've gone with Gmail search account strip, each of those custom elements does its own thing, focus on its one thing. We're separating out functional concerns. You could say that you can, if you look up separation concerns on Wikipedia, it talks about CSS for presentation, HTML for content, and JavaScript for behavior. That depends on how you structure your applications, but obviously you can still do that with web components too. We're getting natural encapsulation, so we know the benefits of software developers of encapsulation. Shadow DOM naturally supports that. It doesn't offer JavaScript protection. So at the minute, JavaScript can reach out of an element and mess with your page. In some ways, iframe is probably right now better for that. So if you need that sort of functionality, you can look at iframes. But there's talk in version 2 of web components to offer that level of JavaScript protection too. I'm not going to do that demo. There are benefits of loose coupling as well. Now, again, you're not absolutely forced to do this, but we've got custom events, and we've got the element has an API. It has the standard DOM API and any API that you want to define on it. So as a developer, you interact with that API. You bind to events on that element. You don't dive in and start hacking around with the internal code. Or you could use an existing framework. So the idea of the services layer in things like Angular and Ember, or a separate services layer, is still very relevant and might still be a nice way of approaching that with web components. I've got 6 minutes, so I probably will show this. So, I mean, most people have seen the ability to, I'm registering for a click event here. When I get a click event, I'm going to create a custom custom event, a cheese event. I don't know why. And then I'm going to dispatch that event. And here, I'm actually registering for the cheese event on my element. I don't know, again, why I would want to do that. And I'm going to alert cheese. So we've now got this, loose coupling through events in the DOM with custom elements. We can also define functions. So I can get access to my this element and then call start spin and stop spin. So it's the stuff oh, that didn't work at all, did it? Ah. OK. So we've got that. Again, we've been building this sort of stuff. We do that with library components anyway. So as long as we've got that level of abstraction right, whether it's a web component, a native web component, whether it's a library component, it doesn't matter. It actually supports change. This idea that we can migrate different pieces of our application over time. As long as that API, the surface area stays the same, we can change the underlying implementation. Encapsulation and loose coupling help that sort of thing. So obviously encourages reuse that I've already mentioned. It's ease of sharing and composition. Something else that, as you start to scale and build a large application, you'll see the benefit of is that you have high cohesion. You have functional cohesion. You have your HTML, you have JavaScript, you have CSS, you have your images, you have any assets related to a single component on disk together. There's a lot of benefit to that. There's still a bunch of problems. We don't know what's going to happen with HTML imports. At the moment, if we're using HTTP, basic HTTP at the minute, not HTTP2, then if you've got an HTML import and it's including loads of assets, then you're making loads of network requests. But HTTP2 will solve that. Until then, there's something called Vulkanized, which will deal with concatenation. Will JavaScript modules help? What happens if multiple components want to share the same script? jQuery, are they all going to use jQuery? Are they going to use different versions? How do we deal with that? I mentioned that JavaScript can kind of reach out and reach in right now at the minute in terms of web components. But version 2 will deal with that. How should components communicate with each other? You can still write a component that feels like it's its own thing, but if you write code that reaches out and grabs hold and relies on another element being present in the page, then you've broken that nice independence, that encapsulation, that separation of concerns. So maybe there needs to be a defined way of supporting cross-component communication, or maybe we just leave that to the developer. I think you've got to be able to import certain resources into the Shadow DOM as well. So in summary, I really understand custom elements. I understand the benefits of it. I think they're really easy to use, but also very powerful. I've spoke about the benefits of natively supporting this sort of functionality in the browser. We get all the benefits that the browser offers, and that's why we eventually, once we know that it's something that we're all going to use, we push it into the browser. We also have standards, so we have a standard way of doing something. So no matter who comes along, if you follow a standard, we all understand how that piece of functionality works and how to create a new one or how to maintain an existing one. 50% of you are already building componentized web apps, so it's aligning with the future anyway. And the trends, hopefully, and best practice definitely aligns itself with web components. There have been 2 attempts to do componentized web apps already. Microsoft had an attempt back, I don't know, ages ago, maybe i5. It's probably been removed in Microsoft Edge. And was it XBL2 in Mozilla? So we've tried to do this sort of stuff already, but they just haven't taken on. Now everyone's come together and created this standard. And I do think web components are the future. Loads of resources to go and have a look at. I'll share these slides afterwards. And it's definitely, there was a decrease in interest in web components for a while, but it's really picked up again recently. So I've got 2 minutes for questions, if anyone's got any questions. Yeah. Okay, so the question is there going to be any benefit from defining custom elements in this way that the browser will ultimately understand and be able to optimize? I don't know. But the idea that you move towards using web components that the browser natively understands means that the browser vendors know that elements are built in certain ways, so they can optimize for that sort of thing. So I should certainly hope so. Any other? Well, maybe you can ask Christian upstairs on the IA booth, because he'll hopefully know. Any other questions? Okay, yeah. Okay, so the question is whether or not there's any problems in terms of importing XML, importing like references to scripts, prototyping things, timing issues, basically, right? Is that the question? Is it around timing issues? Okay, yeah. Oh, well, I mean, definitely there are timing concerns, and that's one of the things that's ongoing at the minute in terms of discussions. When things are constructed, whether things exist yet. Definitely around asynchronous includes. I think HTML imports includes things asynchronously. Obviously one of the concerns because it's slowing the page down. I think at the minute you're meant to, there are a bunch of things. There's a podcast that I've referred to in the resources. Wilson Page was on it. Christian Hellman was on it. A bunch of other guys were on it around discussion of specifically timing issues, asynchronous loading, and so on. That's time. Thank you very much for coming. There's some T-shirts here, push your T-shirts, some stickers. So thank you very much.